Hello everyone, this is Mr. Swan and I'm here to bring you your lesson today through a screencast. I know it is not as amazing as it is to watch me every day in front of your class as I entertain you along while bringing you beautiful scientific knowledge, but it is something that we'll just have to do for just a little bit and we'll have to get through this time together. Now, one thing I should mention is I don't know how to edit these videos, I only know how to cast them. So if I make a mistake, I'll let you know immediately, but I won't be able to remove it. So I'm sorry. One thing you want to do right before we get started is to pull out your note packet. There's one change I want to make based on how it printed. I believe it printed a little weirdly. So I'll bring that up when we get to it. If you'd like to pause this video as the students pull out their note packet, feel free to do so. Besides that, let's get started. The moon. By far, the moon is one of my favorite things in earth science, mostly because as you go about your lives, you see it all the time. You cannot really go outside at nighttime without taking a look up in the sky and seeing that beautiful moon just up there shining brightly. And I think it's nice to know how it works. I think it's nice to know the names of the phases. I think it's nice to know how it influences our world, especially if you live by a coast. And that's what we're going to learn about today. Some things about this, in all fairness, will be easy. Some things about this will be very difficult and will take some time. So we'll be spending maybe a few classes working with the moon to get you very, very comfortable with that. So let's go right through the first slide. General information about the moon. Well, the moon rotates. Just like Earth, the moon actually spins right around on its axis. And most people don't notice. Bullet point number 2. The moon revolves around the Earth. It does so just kind of like how the Earth revolves around the sun, and a lot of people notice this. So why do they notice one and not the other? Well, mostly, I'm going to skip point number 3, because I believe you all know that the Earth moves around the sun, and since the moon goes around the Earth, it doesn't go in the exact kind of nice elliptical orbit path, or smooth path around that we usually do. But the point of bullet point number 1 and number 2 lead to bullet point number 4. The same side of the moon always faces Earth. So what does that mean? Well, the moon rotates extremely slowly, about 27.3 days to spin around one time. Earth takes just one Earth day. The moon takes 27, so a lot longer. The moon also revolves around the Earth in also 27.3 days. Kind of a coincidence, but not exactly, and I'll get to that point as well when we talk about tidal locking. But because that it does take the same amount of time for the moon's period of rotation as it does take for the moon's period of revolution, it leads to a neat little fun fact. You only ever get to see the same side of the moon. That's it. That was a dramatic pause. You only ever get to see the same side of the moon. You never get to see the back half of it. And if you really think of humans, the species of humans, how many thousands and tens of thousands of years humans have looked at the moon, they've only ever seen one half. No one's really gotten to see the back half until more or less modern times. So it's nice, and we'll actually get to take a look at that. We refer to the back half of the moon that we have never get to see normally as the dark side of the moon. This is a little bit of a misnomer, because when people think dark side, they think no light. The back half of the moon does get light. It does get sunlight. But that sunlight is at a direction where we just cannot see it. So that becomes a problem. And I know you're all waiting for that picture of what does the moon look like. Well, you already know what it looks like from the front half, but what does the back half look like? And we eventually set up probes and astronauts to the moon, and they took some pictures, and they finally sent it back down to us, and it looks like that. The picture on the right. I know you're saying to yourself, it looks very similar. Not exactly, but similar. Which is kind of what we expected. When we sent those probes, we were like, well, it's probably going to have a whole bunch of craters on it, which it does. And it'll probably have some of these big black splotches. Those are called Maria. And it didn't. So that was a little bit of a surprise. And the reason, well, what are those, actually? I should explain. Those big black splotches are actually dried lava pools of basaltic rock. When you see lava on Earth in different volcanoes, any kind of pictures, eventually hardens into a rock. The back half does not have it. This led to an issue. This rock is more dense. This rock is not. So that means that the more dense side actually eventually over time, and since the moon spins around, it actually slows as it does so. Eventually it slows enough that more dense side and the Earth's gravitational attraction kind of held on to that. So that is why we only ever see the one half of the moon. We call that tidal locking. This led to some other neat discoveries. The crust on this the front half of the moon that we see is thin. On the back half, it's not. Fun fact, nobody knows why. There's a couple theories. One is that the moon was a lot closer to the Earth back in the day. And when I say back in the day, I mean billions of years ago. And the Earth was molten rock and was so hot that it thinned out the crust through some volcanic, or should say not volcanic, volatile chemical reactions. And the back half just didn't get it. Another theory is that a smaller, kind of tinier moon-like object, maybe about just the size of my mouse that I'm kind of putting right over here, maybe I don't know, maybe eighth of the moon, came at a very, very slow pace, super, super slow, and then just kind of touched the moon and kind of turned into a liquid, didn't really vaporize, and kind of splashed the moon with some of this volcanic rock. Well, lava that would eventually turn into volcanic rock. Most people believe the former theory than the later. But the jury is still out, and nobody really knows for sure. But that is why we only ever see one half of the moon. And the good news is you don't have to memorize those numbers. 27.3 days for rotation, 27.3 days for revolution is in your reference table, which is great. You don't have to remember that. The bad news is you do need to know what a lunar month is. And a lunar month is 29.5 days. It is the amount of time that it takes between new moon phases. And that's a little bit strange, because you would think that the amount of time it takes for the moon to go all the way right around the Earth would be the same amount of time for it to start a moon phase and eventually go all the way through them and start the next one. That turned out not to be true. And it's hard to explain. If I was there pretty much in person, what I think I would do is I would take a volunteer from your class, whoever that might be, and I would take another volunteer, and I would ask volunteer number 1 to just run a circle around volunteer number 2. And they might look at me kind of strangely, and they would say that's not very difficult to do, and it's pretty easy. And they would walk right around it and make a pretty nice circle, and it would take a certain amount of time. If I said for the volunteer that's getting walked around to run away as that other person is trying to run a circle around, now it is longer. It is harder for that person to do it. They're not really making a great circle around that first person. And what I mean by that is that when the moon moves around the Earth, it takes 27.3 days, but the Earth is not standing still. The Earth is still barreling around the sun, right around about 50,000 miles an hour, and the moon is still trying to go right around. And when it does so, it lines up differently than we would expect. And a nice visualization of that is this one. This is the difference between what they call a sidereal month and a lunar month. A sidereal month, you have the Earth, moon, and sun lined up in a nice straight line. This will make a moon phase called the new moon. That new moon and the moon in itself will actually eventually go in one 360-degree orbit all the way right around. It's pausing real quick. That little red dot is where the moon used to be. And it's going to wait till the moon goes all the way right back around to that dot. So one 360-degree circle. And it did it. That took 27.3 days. That is the sidereal month. Except now the problem is the Earth, moon, and sun are not lined up anymore. They were, but now they're not. And so for the moon to go back in front of the Earth, so it goes Earth, moon, and sun in a nice straight line, takes 2 more days. And that is the reason why our moon phases and our revolution of the moon around the Earth do not match up. That little bit of a gap, that little bit of a lag right there, about 2 days worth of time is the big issue. And I'll show you to you one more time. You have the Earth, moon, lined up in a nice straight line. You're waiting for that moon to go all the way back around one more time, which it does. is no longer in a nice straight line as it would be to the sun. You have to wait 2 more days before it does so. You can actually see the angle right there. That is the difference. And it continues to go on and on and on. So, what does this mean for you? Well, what do you need to know? You need to know the moon rotates. You need to know that the moon revolves. You need to know that that amount of time is the same. And it's probably a good thing to know. That's all written down in your reference table. So you don't have to memorize it. It's good to know, I think, just for a general life tip. I'm not sure if this will ever be tested on this, but the same side of the moon always faces Earth. The harder thing to know, the thing that students most often get wrong, is the amount of time for a lunar month, which is 29.5 days. That is not written in your reference table at all. You just need to know it. You just need to memorize it. You need to know it's about a month, but not quite. It's not even a full amount of days. It also includes that half a day in there. So you need to know the amount of time between those cycle of phases. And you need to know the difference between what I mean when I say a lunar month and a sidereal month. So this slide, even though it kind of looks a little simple, is actually a little bit harder than you would think. And I'm sorry to say it's going to get a little bit harder after that, because now you also need to know the moon phases. And what is a moon phase? Well, a moon phase, really quickly, is how much of that lighted half we see from Earth. And this is probably what makes the unit so hard, is that not only do you have to have a perspective of how does the objects look from a view from Earth, but also how the objects look when you're not on Earth at all, like when you're way above it, millions of miles above. Just like that video we just watched, which is, you're looking down at the Earth and the moon and the sun. So you need to really know 2 perspectives. That's going to be a very common theme in this unit. It's going to come up over and over and over again. So for the moon phase, pretend you're back down on Earth and what you see when you look at the moon. How much of that moon is actually lit up by sunlight? In this picture, you can tell which way the sun is because, well, that's the half that's lit up by sunlight. The other half is in darkness. As the moon revolves around the Earth, that amount of light that we see is going to change. It will sometimes get bigger and then sometimes get smaller. So here's another example of the 2 perspective. Imagine you are now millions of miles above the Earth, looking down. You see the sun, you see the moon, and eventually you see the Earth. If you just stayed up there for a full month and just watched, you'd watch the moon go from one position to the next, to the next, to the next, to the next, to the next. And this is exactly what it would look like. If you watched the Earth, you'd watch the Earth spin from, in places like America going into daylight, and eventually spinning into darkness, then back into daylight, about 27-ish times as it did so. That is what the viewpoint looks like when you're not on Earth. When you're on Earth and the moons are at these locations, this is what they look like. These are the moon phases and the moon phases names. Starting with new moon, waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, third quarter, waning crescent. I highly encourage you, even though I'm not there to make you do it, to say the words gibbous and crescent, waxing and waning out loud, to get used to saying them. The faster you get used to saying them, the more likely you'll be able to use in conversation, which means more likely you're going to learn it. So what you need to know is the order of those planets. I should also make it, and let's pause real quick. I believe this slide needs to be kind of redrawn for yourselves in your note packet. I don't think it printed correctly. On the right side should be dark. The left half should be white. So just kind of shade that in for the Earth as well. Feel free to pause this video to give them time to do so. One thing you'll need to do is you need to learn the moon phases. There are some things I know, and you know this too, is like, why do we learn this? And you kind of sometimes have those questions. For me, the moon phases, and my answer for this is that you see it all the time. And people always kind of wonder, like, hey, what phase is that? And they're truly, if you can actually answer that, they're usually slightly impressed, at least in my personal experience. And I have some funny stories about that too, I'll tell you sometime. And so we're going to start out for the first one, and we'll work all the way through. And I will tell you some of the common ways people try to memorize this. I'll tell you my method, which is a little out of the ordinary, and we'll get through it. I would start off with the ones that you know. The full moon. Everybody knows the full moon. It's highly used in pop culture all the time. Everybody loves werewolves. So full moon is that you see the moon is totally filled up with light. From this perspective, what you're seeing is that, well, it's during the nighttime, and you're seeing only the half that's on the left side of the cursor right here. I have some other moon simulation websites that you're going to see that really help to illustrate this point. As you kind of go and as it works its way around, eventually the shadows takes over, and then you eventually go into waning phases, and then more light, so it goes into waxing phases. The opposite of the full moon is the new moon. The new moon has zero light. I cheated a little bit in all honesty that there's a tiny little sliver of light here. This is like the day after the new moon. I just didn't want you to see something that was totally black to think that I just deleted it. But it is actually there. So a way that I kind of think about it is that if you draw this diagram, that if you were to kind of add up the moons that are opposite of each other, they will always equal out to a full moon. So if you take the new moon, which is like no light at all, and the full moon, which is 100% light, you add them together, you get the full moon. I think when you take a look at the quarters, it illustrates that point very nicely. If you take the first quarter, which is lit up on the right side, and the third quarter, which is just lit up on the left side, and you add them together, so you take those two slices, push them together, that makes a full moon. Waning crescent, waxing gibbous, added them together, this little lit up crescent on the left matches up with this one, full. If you take the waxing crescent, like the DreamWorks symbol, and then or DreamWorks logo on the beginning of their movies, add it up to the waning gibbous, full moon. So when you're kind of drawing them out, that might be a good way to help you see if you're drawing them correctly. Other different patterns that are in here, the gibbuses, almost filled with light, they're right next to the full moon. The crescents will always be right next to the new moon. And the way that I remember waxing and waning is actually from Karate Kid. An awesome movie you definitely should watch. Waxing, you're adding, like when he's doing talks about like waxing the car, and this karate teacher was saying, this is the better way to do it. You're adding wax, like you're adding light to the moon. So during the waxing parts, the light is increasing. Waning means another word like wane, to remove, means light is going away, so it gets smaller and smaller. And then lastly, the way that I help myself remember the moon phases, in all fairness, is totally abstract. It makes sense to me. It might not make sense to you, but here it is. We read from left to right. So when you read a book, you always read from left to right. That's how we're trained. That's how our sentence structures work. When I look at the moon, I think the moon is the opposite. The moon works from right to left. So whatever is happening on the right side of the moon will eventually happen to the left. And that's just the way it goes. It starts on the right, works its way left. So for the new moon, light starts on the right side. And then it gets a little bit bigger. So then it goes in the waxing crescent. And then the next one, it gets about halfway across. And then waxing gibbous, it gets to like, about 75% of the way across. And then full moon, totally filled up with light. And then the shadows start. And the shadows start on the right side. So whatever's happening on the right side will eventually happen to the left. So shadows start, get about halfway across, 3/4 of the way across, and then eventually cover it all the way on up. You need to know the phases of the moon. You need to know how to draw them in a picture that matches. I think it's good to know for yourself, for your life, for your experiences walking around, and be able to take a look up at the sky and know what's going on. And you also need to know for your test as well. A harder one to do is you need to know which one of these phases of the moon, you don't have to draw them this time, now you just need to list the name, is all the phases of the moon, such as what phase is this one if you were shown this diagram. Well, that would be the new moon, because the new moon is always between the sun and the earth. That means the opposite of the new moon is the full moon. The full moon would have to be this one. First quarter would be down here, third quarter would be over there. What makes this difficult is that you can't really memorize the picture, because you can take this diagram, you can take the sun and flip it and make it all the way over here on the right side. And if you did that, well then this part, the whole picture would have to flip as well. The right half would be all lit up with light, the left half would be dark. And that means that this part would be the new moon, and on the back part, this would be the full moon. So you can't really just memorize the order of phases, even though the order doesn't change, but it can rotate and move right around. You could have the sun on the bottom part of this diagram, and that will shift all those phases around accordingly. That is what makes this hard. That is what will take time. When will we use this? Well, I mean, for your test, I will tell you right now. I'm going to give you a question that says draw and label all the phases of the moon. So always a good way to get started immediately. Moon phases and extra help. These are animations that will help you learn the phases of the moon and how it works. I will come back to these in just a little second, but I just want to do the tides real fast, and then I'll move on to a little activity for you guys to do in the back. The tides. We don't live near an ocean. That is true, but the tides still affect us greatly. So, what are the tides? The tides are a daily rising of water, and they're a daily sinking of water. Of the ocean water. So that means they happen every single day. So sometimes they get higher and sometimes they get lower. And if you've ever been to a beach, you probably have noticed this. When you got there, maybe in the morning, the water level was at a certain height, and then a little bit later on, it seemed to have changed. Maybe it moved out, or maybe it got closer. The tides are caused by the pull of the moon and the sun, and the gravitational pull because of the mass. The moon is more important for the tides. The high tide is actually always going to follow the moon. Each location on the Earth will experience 4 changes in daily tide levels because the Earth is rotating faster than the moon is revolving / pulling the tides. And to help you with that, this won't print out very well on your slides, but it shows very, very nicely on a video or PowerPoint because I was able to make that moon rotate, a huge victory for me. So the tides of the daily rising of high tide, the daily falling, which is called low tide, and here is, if you can follow my cursor, there is North America slowly spinning right around while the moon pretty much remains still. The Earth will have to spin around 27 times before the moon goes all the way around us even once. So we're spinning a lot. Moon's not moving much. So the water is always going to be pulled and kind of bulged over towards the moon, wherever the moon is. No matter where the moon is going to be, that's always where the high tide is always going to be. And we spin in and out of that. So right now, we'll start the full day. We'll say right here, high tide. A couple of hours later, low tide. A couple of hours later, high tide. A couple of hours later, low tide. Then back to the high tide. And that is one full day of time. We got different names for tides. One is called the spring tide. That's everybody's favorite tide. Is that I'm going to show you some great pictures of them. People only take pictures of the tides when they're a spring tide, and there's a reason for that. It's because they have the highest of the high tide. So the highest water level is going to happen during spring tide, and the lowest of the low tides will also happen during spring tide. So if you go out near like a beach that is experiencing the tides on a spring tide, that only will happen when the moon is lined up with the sun. That is during a phase of the moon. If you think about it, when it goes sun, moon, then earth in that straight line, that would have to be the new moon. People will go out and they'll spend the entire day photographing and filming tides, and they'll see the dramatic change between the highest of the high and the lowest of the low, which always happens at a perpendicular 90-degree angle from it. The moderate tides, called the neap tides, is that the moon pulls in one direction and the sun pulls in one direction. High tides still follows the moon, but the tides are more moderate now. So the high tide isn't as high as it used to be. The low tide isn't as low as it used to be. So there's still change, but not really a lot. But really the picture says it all. This is the Bay of Fundy to the northeast of us on the coast. Why people like it so much is that they have extreme tide changes, some of the biggest in the world. And you can go out here like in the morning, and you just kind of go hike out to these rocks and take a picture to kind of give you a sense of scale. These are adults. And that person goes up to probably about right here on this rock. So that's probably about maybe 5-6 feet. So a pretty dramatic change. You go out there 6 hour, go out there, you take your photos, you come back in, maybe you go hiking right around or, visit some stuff. And then you go back, you can rent out a kayak and you can kayak out there and you'll take some sweet selfies. And then you see how much the tide changed. Since slow and time-lapse cameras were invented, you can really get some great videos of that. Here's one of Mont Saint Michel, a place in France, built over 1,000 years ago. I think maybe in the 800s actually. And I'm not really sure if it's a cathedral or wherever it used to be. It's more or less a tourist attraction now because it's built at such a low elevation. This is all sand pretty much from a beach that the ocean level, the tides will surround it. It becomes an island. So you can kind of see the tides starting to come in just a little bit to the right, and then also going to be coming in to the left as well. And then, this is over the course of just a few hours. and fills it all right in. This is probably not a spring tide for this place in particular. You can see the people getting pushed back. Let's go back just a little bit. Right there, like right here off to the side, they're getting pushed back. Right, because the tide's still filling in. During a spring tide, this would actually fill in enough to cover a good section of this bridge. So you would actually have to wait for the tides to go out before you could actually leave this island. I know I just talked about Bay of Fundy with a picture, but here's the Bay of Fundy. Nice time lapse. This is, these boats draw on gravel, and the tide comes up, brings them on up. So he's going through the high tide. Now it's going back in through the low tide. Kind of helps, I think, really understand the saying, you missed the boat. Because we got to sail with the tides, because if you think about where those time periods happened, 1800s, 1700s, you had to sail with the tides. There's no way of beating it or dragging that boat out to sea. So you really kind of had to go with them to be able to get out of there. So I like the tides, mostly because those pictures and film are just fascinating. So what you're going to do, and I'm done with the notes, at least for right now, is that I'm going to give you time to work on learning the phases. Learning the phases, learning how the moon moves is time consuming. It is difficult. It will take practice. So I have a couple different resources to use. I have a couple different links on here, and we can kind of go through those real quick. This is, I believe, the first one. A nice simulation. Shows the green dotted line. Anything facing the Earth is where that's the part of the moon that we see, and the part that gets moved into our viewpoint that's lit up, then we see what moon phase it is. That is the crescent. And as it continues to go right around, you can drag and move it if you want. It goes into first quarter, and eventually goes into a full moon, and eventually goes into a third quarter, and then back into a new moon. And the process starts over again. There are like tiny issues with some of these simulations. They're not absolutely perfect. They might have an error. If you figure out what that error is, maybe I'll give you some extra credit. But otherwise, it should work out. Here's another example of one. So a person kind of moving with the sun, and you can actually show the angle that it moves, right? This little picture on the bottom is actually, you're able to drag that right around and move that, and actually move the sun right around to it. Next one. This one shows where the sun is. It shows bisectors. It shows shadows. And then you can actually move where the moon goes. And you get kind of a good idea of, when you see from a top-down perspective, the moon always looks the same. But from an Earth perspective, so if you kind of like move it from the viewpoint of Earth, and you start moving the moon around, like, well, this is a new moon. If you move the moon over here, and from Earth's perspective, it no longer looks like a new moon, right? So that'd be light on the right side, so that'd be the first quarter. There are two other little videos on YouTube I found that just quick diagrams of the difference between a synodic and siderealed month, and how that works, and some good explanations about them. Quick, about 2 minutes each. So this is all about practice. This is all about trying to get good with the moon phases. If you can draw them, you probably will be able to understand them. So it's also a good thing to practice as well. And I have a sheet for you guys to work on, and give that a go. And then let me know how it goes. If you have any issues, please feel free to email me. I will be able to email you back with any answers. Okay, well, I hope you enjoyed my screencast, and have a nice day.